Thank you all for attending our session that talks about unstructured data and different data modalities and how can you build a strong foundations for AI. We're very excited about this session. We're very excited to share some of our experience from the real world as well. And we couldn't be more thrilled to be here with you. With me on the stage, I have Avinash Reddy Irupaka, who's our speaker from customer side. He's a leading principal engineering at Bayer. I also have Shiv Narayan. He's our product lead for SageMaker Unified Studio. Throughout our session, we're going to be looking at multiple demos as well as some of the real world examples. So thank you, Avinash and Shiv. So I just want to start by asking, how's everyone doing? I know it's a speaker, I cannot hear you and all that, but it's all good. Thumbs up is good. So what we have done today is we have structured our conversation and story in these 5 or 4 different sections. We're going to talk about a very important topic called data readiness for AI, right? We are talking about unstructured data today, among other modalities, but it is important for us to align and land on this foundation that talks about how you build your data platform, which is ready for agentic and AI and workflows and things like that. We're also going to look at different data modalities. So my name is Navneet. I lead the data and analytics for AWS for life sciences customers. So most of my examples are coming from the life sciences world. Having said that, a lot of my other partners and colleagues in the organization work with different industries. I see a lot of similarities. So we're going to talk about that too. Then we're going to look in the demos for Amazon SageMaker Unified Studio, Amazon SageMaker Governance, that how can you build a platform that can serve not only structured but unstructured data. And finally, we're going to hear from Avinash on the real world examples or real world use cases of Bayer. I want to start by this slide, which I'm sure you all are very familiar with, not maybe the slide, but the concept, right? So as you know that the lot of interest and a lot of work that is being done in building generative AI and AI applications, agents and agentic AI applications. This is a 40,000 feet view maybe. Of course, we are not drilling down, but if you look at this pyramid, at the bottom of all this is a data foundations, right? And data foundation is something which is evolving and changing with the need and the kind of modalities that we have and also the type of agents that we are writing. So to write an AI application, to write an agentic application, you need to rely on the data foundations. And today we're going to talk about how you build that, what are some of the best practices, what can you use on AWS as an example. So again, we're going to start with this today. So a few years back, there was a paradigm in data called data mesh. Have you heard of that? Some of you might have heard of data mesh. And it was an interesting paradigm, actually very, very timely at that point, because that was the first time when someone was building a paradigm shift on data that involves people, process, and governance. Not that the governance wasn't done before. It was done before. There were MDMs, there were data governance leads, and things like that. But the distribution of data assets across your organization was something that data mesh was targeting, along with people, process, and technology. In last couple of years, we have seen the same paradigm shift on the generative AI side, right? So keep that data mesh concept in mind. I'll try to merge them together here because how can you leverage your existing platform in actually serving up your agents? So we started from traditional AI/ML. This is an era where you're writing neural nets, deep learning models, machine learning models, statistical analysis, regressions, you name it. And most of the uses there was you have a notebook or R Studio or something like that, which is enabling your data scientists to run analysis. And this is the typical. Now, then came the generative AI, so large language model, building summarization, building notes, and building other sort of content that can be leveraged for your business. But with the introduction of generative AI-based workload, there's another thing that was very much important along with the data is the context, right? That's where you have technologies or RAG and stuff. Lately, we are seeing a lot of interest and a lot of workspaces, workloads that customers running building agents, which is basically, in my opinion, a unit of work that gets a specific business metric or a specific work done for you. And we're looking at multi-agent collaboration now. So it's not only one agent, but it's a combination of agent with orchestration, with chain of thought reasoning, and all those things that is helping you building a workload that serve up for your business. And there are several examples in this space. Now, what is important when you think about building data and you think about building these agents? The one common theme between the two is that how are you utilizing your data platform to serve up these agents, and how that is any different from what you were doing previously. As you see in this slide, at the top, we have the foundation model, the models that you would be utilizing to build those agents, right? But that alone is not sufficient. You need enterprise knowledge at the bottom, as it says in the bottom of the slide. So think about the shift in the data, paradigm shift with the data mesh, and think about the paradigm shift in the Gen AI, which is in this slide, we're calling it multi-agent collaboration or a mesh. So data is no longer the only product that you're sharing across the organization. You're also sharing agents and other things. So AI is only smart as your data, like we all understand that. And data can be a different type. Now, this is a life sciences example. In your organization, you may be having your existing data, that is your relational databases, your warehouses, your S3 data, your S3 tables, or one of our partner solutions. This data typically is largely structured and also unstructured, but largely what we have seen mainly is that you have rows, columns, some sort of a Parquet document, all this stored raw, but you can query that. The new data that you're creating, and this is where we're seeing a lot of data which is getting created in an unstructured way. In my example, and then Avinash will talk about that in the later also, that a lot of data coming from these instruments, the lab instruments, a lot of data coming from your genomics information and gene information, and other verticals too, like social networking, your clinical notes, your images, PDFs, and things like that. All the data that you're creating is largely unstructured along with this. Now, you have to work with both. You cannot leave the structured data. You have to make sure that your guidance and your implementation has both of those things. And then the third-party data. This is what you acquire from other partners, other sources, and things like that. So how you combine these different data assets and spread that in a data mesh-like setting with the right pillars so that you can serve up your agentic platform as well as the human usage and things like that is an example of a multimodal data science. Now, even though you're not, say for example, if you're not from the life sciences healthcare industry, it still is very much relevant for you. At the center of this diagram, we have somebody called a patient, right? A patient is someone who has certain data records like admissions, discharges, labs, conditions, procedures. We all have that, right? We all been to different healthcare facilities and we have this data. Now, if you note that you have the EHR data, which is largely structured, other than the clinical notes and the summaries, but you also have the clinical notes, the dictation in physician room, or a vaccination data, or a social geographic data. This comprises of a multimodality in any organization, right? So you want to make sure that as you look at this example is that identify the modalities in your specific lines of business and identify the different type of modality and then create a common model that can help you govern the data, that can help you build the agents and things like that. On the right-hand side of the patient, have the omics data. Now, this also has a large volume, like, for example, microbiome or metabolome or the proteome. All this data that you have is largely unstructured and requires a great deal of analysis that you need. Now, you might ask that, I've been building my data agents, I've been building my data platform for a number of years now. My data is very good. I don't have to do anything else. What is that I need to do to make my data unstructured and structured data, something like what we've seen in previous slide, ready for the AI? Now, this is a very small example. On the left, you see, which is the current state, which is the state of data scientists, data engineers interacting with the data. As you can see, a researcher investigating drug interaction knows where to start. A database, a molecular database. They can then go and understand the significance of specific protein bindings and things like that. So they start with a very narrow focus approach, and they know exactly what they're looking for. Now, you may be having in the right, best possible way, the right quality, the right access, and things like that, and they're good with that. The challenge, that it doesn't scale, right? So if you scale that to hundreds and thousands of data scientists, if you scale it to hundreds and thousands of different data models, chances are you need something that can help you scale. Which brings us back on the other side, which is that, hey, I can write agents that can go against this data and really scale it further. What is the challenge there? It starts with speculative exploration, right? Because you're pretty much throwing every single data elements to those agents, and then they are doing for example, in this case, I have an agent is tasked with analyzing clinical trial, effectiveness, might initially request all the available trial data, and then further filter it down. So what is the right balance? And the reason it's important for us to note now better, more than ever, is that when you think about the right balance between how much you want to provide to the agents, and how much you don't want to provide to the agents, the data modality plays a big role. For unstructured data, a lot of data, something that agent can analyze, bring the value out of it. For structured, you may be requiring a far more governance control and things like that. So we have these building blocks that you think about, again, at a high level. My colleague is going to go deeper into some of these topics. But if you look at this one, we are saying that how you build data ready for AI using 3 building blocks, right? The first building blocks is contextual information. So how do you create a data ready for AI? By bringing the right context to the data, okay? The right context means several things. It could mean your enterprise knowledge, your ontologies, your metadata, your business metadata, and things like that. The second thing is that you need your data platform is the tool provisioning. This is how someone is going to be accessing your data. Now, remember data mesh? They had this concept called endpoints, data product endpoints. So data product can be called using an API or a SQL or something like that, right? Now you want to make sure that your data platform is ready to be accessible by different toolings and resources, something like an MCP server, something like an other agent, and things like that. And then finally, data maturity. Now, this is a bit tricky because data maturity for structured data means different thing, for unstructured means different thing. But it doesn't matter to your data scientists. Like, they want data to be fully matured. So as you think about modalities and unstructured data, I would highly recommend that look through these 3 different pillars. Now, just a show of hands, and how many of you are actually utilizing your business metadata as the context information for your data assets? So if you, and I can tell you that the metadata is one of the largest wealth of information outside of your data that can provide a lot of information for your agents to work for your outcomes. Which is my next slide, that if you look at the metadata a few years back, it was largely treated as documentation. Like, I remember sitting with my team, working on metadata, building data dictionary that kind of explains what data is. Documentation pretty much, right? You go through multiple Word docs, you go through multiple data dictionary, not that it was bad, very useful, right? But it was largely a documentation. Whereas now, in the contextual world, and by the way, the data context metadata is just one of the contexts. There are other contexts depending on the industry that you work with. Now, in the GenAI era, metadata is actually an intelligent amplifier, right? So you can use metadata for business context, your glossaries, your enterprise knowledge, something the data steward can work with, and the relationship discovery across domains, as an example, and of course, a real-time trust. So think about your metadata, and it's even more important for your unstructured data, because structured data, I can still query and make some sense out of it, right? Or I may be having at least basic information of the columns that it has. But for unstructured, it's largely unknown for me until I actually tap inside the file and see what is going on. So therefore, it is more relevant for you to think about a contextual information. So you build your data platform, have those 3 pillars. In the context, start with business metadata. So how do you get your unstructured data ready for AI, right? So on this screen, you see that you have different types of sources. Some video transcription is coming, some plain documentation is coming. The 2 things that I would like you to take as an outcome of this talk, of course, it's a complex topic. As you start working, I'm not overly simplifying any of it. But the 2 areas that we will be focusing a lot today is, one, that how do you build a unified governance of your data irrespective of its type and modality, right? Even if it is structured or unstructured, your data needs to be treated the same way, and so as the agents, for example, right? And the second thing is, specifically for unstructured data, how do you use some of the capabilities that we have in Amazon Bedrock and Amazon Bedrock Agent Core and Amazon SageMaker that you can utilize to build insights from the data? Remember, governance is first, building insight is second. So those are the 2 areas that we uniquely focus today in regards to unstructured data. But as you can see, they could be structured plus unstructured here as well. And of course, in most cases, like in my patient's example, you have both of them. And so it's important for you to understand that how you can merge the experience there as an example. So I'm going to talk a little bit on the data founding layer, which is something that very much linked with what I presented earlier on the 3 topics. So you look at the bottom of this layer, we call it data readiness for AI, right? This is where you have the data foundations, the structured, unstructured, interoperability, and things like that. This is how you store your data. Best performance cost, modality. If I have a data in Iceberg, I would store that in S3 tables as an example. If I have data, unstructured data, store that in S3 general purpose bucket. If I have warehouse data or structured data, I'll store that in RDS or Redshift warehouse or something like that. If I have unstructured, I'll just simply store that in my S3 buckets and then utilize. But however we store the data shouldn't guide the architecture upstream, right? It is just the storage at the end of the day. What guides the architecture upstream is that how you interact with the data. That's where the interoperability is very handy. So it's something like Iceberg-compatible data as an example. On top of that, to have your data ready for AI, you have context, tools, and maturity. Remember those three pillars? Context is extremely important for your agents to work with your data. Without that, it's going to be speculative exploration for the most part, right? And context is not only business metadata. There are other things like clinical ontologies in my world, in your world, it could be other ontologies and enterprise knowledge and things like that. You have that platform, then you start building agents. So we have agents, in my case, healthcare life sciences agents, but you may be having some agents which specific your industry. We have offering there which you can use the accelerators that our team has built. You have agentic workflow, you have data accelerators, all that you put in there. Then you build a governance layer, FLAIR principle. Everybody knows what FLAIR is, I'm assuming. Findable, accessible, interoperable, reusable. L is the lineage, which is also something that we've added as part of the. And it's interesting to know that even lineage can act as a context to your data, the provenance, the transformation, and things like that. Then after that, you build an experience layer. This is your end users, like you as a developer, as an IT governance lead. You're building all this platform. And then you build experience layer with analytics, with visualization, and with chat. Those are the typically three what I've seen lately: SQL analysis, notebooks, or the chat agent experience. How do you do that on AWS? You have Amazon SageMaker Lakehouse. This is how you store the data, structured, unstructured, federated into existing sources and things like that. You have the context as the ontology, metadata knowledge graph. Your tooling is MCP servers, APIs, and of course, the maturity is the quality. There are others, of course, maturity principle that you can follow. Amazon Bedrock and Agent Core for building your agents and running your operationalizing in production. Amazon SageMaker Catalog, a unified governance model through which you can unify your governance across any type of modalities of data, including unstructured data. And then at the top, you have SageMaker Unified Studio for building your experience. You have Amazon SageMaker Notebooks and data agents to accelerate your development using AI. And then your Amazon Quick Suite for you to build a chat agent experience for your customers. Really quickly, I have the sample use case for digital labs. This is very healthcare specific. The one thing I just want to call here is that on the left-hand side, you see there are different type of instruments from where the data is coming out, right? And like I said, every industry has something very specific to how they're collecting data. In my case, it's coming through that. All that part is not that super important. What is important is that it's getting stored in the storage layer. Remember the previous slide where I showed you the data can be structured, unstructured. Focus on the storage, how you store the best. Don't store your unstructured data in a relational database. It's not a good idea. It's not cost-effective solution, right? Then we have the lineage, metadata catalog, and the governance built, right? So just those three pieces. Start small, think big, start small. You have to refactor everything. Your environment currently is good enough for you to build these components, starting now. Then you have the semantic layer, extremely important. The semantic, which is an extended concept there of context. What are the semantics for my own organizations, right? In my case, it might be something like, what is a brain tumor? What is a diabetes? And what is something like a carcinoma? In your world, it could be something else. The point here is that you build a semantic layer, and then you build all these consumption models. So in a cloud environment, store your data effectively, build the right context, and then go on from there. So some of the challenges I want to call out before I call upon Shiv. The challenge in processing unstructured data. So far, we talked about the approach of data foundation and what is important for readiness and why unstructured data needs to be treated very similar way, but it should also shouldn't drive your architectural decision drastically. What are some of the challenges? Governance, of course. The governance of unstructured data is very different at the bottom level. It shouldn't be different at the top level. So the findability, the access provisioning, the model and tool selection is a challenge too, where you have the selecting optimal solutions and modality use cases. There's a lot of manual processing for unstructured data, like data extraction, tuning, and parameters and things like that. And finally, the orchestration, managing multiple models for unstructured data is not easy. It's a challenge. Output integration is a challenge and things like that. So how do we address these challenges that can span across the governance of data and the usage of it? For that, I'll call upon my colleague, Shiv, to talk about the next portion where we'll see some of the SageMaker capabilities to address these challenges. Shiv?
All right. Hey, folks, hopefully you're able to hear me. Great. So my name is Shiv Narayanan. I'm a product manager on the SageMaker team, the next-gen SageMaker. So there are two services, SageMaker AI, which is the machine learning and artificial intelligence. The next-gen SageMaker puts everything together. How many of you use SageMaker today? Awesome. I wanted to actually put up my picture, but then I figured I might as well just put somebody who's from Adobe, So today, my goal is to kind of expand upon what Navneet said and show you a bunch of demos on SageMaker Unified Studio. So this is Dr. Smith, and we're going to be walking through a journey. Dr. Smith is a neuro-oncologist treating brain cancer, and we're going to help him prepare for a meeting tomorrow with one of his patients. And one of the patients he's going to be meeting is a 25-year-old person, a female, who has been recently diagnosed with a neurological cancer. And the meeting tomorrow is super important for Dr. Smith because that's the first time that she's actually meeting with Dr. Smith. And the most important thing that Dr. Smith wants to do in that meeting is to instill hope. And the way you do that in the most effective way is to tell that patient that I've actually seen patients like you. And you have hope simply because we've actually done this over and over, and there is really light at the end of the tunnel. But what he's actually doing right now is actually to stare at those documents, the unstructured data, right? And in those documents, one of the couple of things that he's really scared of, like how you probably might be also scared of, is the amount of incredibly insightful information that's scattered across. And this data changes every single document he changes. This is actually the reality of healthcare today. And more importantly, there is demographics data, there is medications, there is procedures, there's treatments, but there is also sensitive data. Now, it's super important for us to be able to provide Dr. Smith the required tools in order to make sure that he gains access to this data, the capabilities to use the latest generation technologies like large language models to help parse this, and eventually help him prepare for this meeting. And that's what I'm going to do now. We as a team are going to actually go through that to see how to actually help him prepare for that meeting. So in order to do this, the most important things is that obviously you have to have the right AWS services to do it. And end of the day, our goal is to actually build him a chat agent. And this chat agent needs to be built with all the right governance controls in place. And traditionally, it was also a little difficult in AWS to do this simply because while we have all the breadth of these services, you have to hop onto different consoles. So what is the innovation that we've done in the past year to simplify these problems? With that, I wanted to talk a little bit about the team that I'm part of and very proud of, the next generation SageMaker. So this is actually your center for data, analytics, and AI. SageMaker is comprised of three important components. The first one is the lakehouse architecture, where you actually store all these documents that you saw. The next one is a catalog, the ability for you to make sure that you actually take all these unstructured and structured documents, catalog them, annotate them, provide the visibility of data quality metrics, associate glossary terms, and you have a unified studio that allows customers to build applications all the way from simple data engineering pipelines to extremely complicated machine learning models and also chat agents with ease, all without you having to switch different consoles. So before we dive into a demo of how we do this, let's just walk through a little bit more details about the catalog first. How many of you use the SageMaker Catalog today? Cool, very good. So what's different about the SageMaker Catalog is, first of all, it's actually built on DataZone's business data catalog. So it really is built on a very scalable model to begin with. The second important thing about the catalog is it's just not like a catalog for structured data assets. It's a catalog for your unstructured data assets. It's a catalog for your business intelligence assets. So it's really much more broader, and we continue to enhance the number of types of objects that we support on that. You can also understand the quality metrics. You can understand the data lineage from that catalog. You can also understand the ability for you to search, and you can subscribe to these assets and gain permissions to data in an auditable and compliant way. So that is very unique about the permissioning model that has been integrated with the SageMaker Catalog. In addition to it, there are other components that I'll be talking through my talk in terms of the guardrails and the responsible AI aspects that you'll actually see in a demo also. So the catalog is an extremely important component for Dr. Smith and his team because as a first step, what we want to do is to be able to take all this unstructured data, catalog them, make them discoverable, provide the right guardrails so that him and his team can actually get the right access controls. The next part is how do you build your applications? So that's where we have the Unified Studio. So Unified Studio gives you the ability in a single console to build all required apps that is needed for your data engineering work to the AI work. For example, if you're a visual person, if you're like more into visual ETL development, we have a visual ETL that is available for you. If you're more of a code-based data engineering, you have notebooks that is embedded in it. You want to build machine learning models, we have foundational models, we have the SageMaker AI models that are available in the Model Hub that you can actually take them, train them, experiment them with MLflow, and then deploy them. And if you're a Gen AI developer, we have the ability for you to build chat applications and prompts, the necessary guardrails, all of them together. So that is the Unified Studio. Now what we're going to do is actually watch a demo, and I'm going to walk you through this. And as a first step to help Dr. Smith prepare for his meeting, we are going to take all this unstructured data that's already available in S3, catalog them, and make sure that it's actually discoverable. That's the step number one. And here's how we're going to do it. Before that, let me just quickly walk you through an important launch that we did a couple of months ago, which is the ability for you to actually catalog these unstructured assets. With this, you can connect to S3, either to a bucket or a folder, take those assets, provide business context, publish those to the data catalog, and then make it discoverable. So with that, let's just watch this demo. So I'm showing you the Unified Studio, and in here, what we're going to do is to go to the data tab of that project. And as you can see here, I have my lakehouse, which is structured assets, and then I have buckets. I'm going to go ahead and connect to my S3 location, provide a name for the data lake, provide a description, specify the URL where the medication records are stored, provide a role, and then we are going to hit the ability to connect. So what this does in the backend is it's actually going to create a connection to S3. And then it is actually going to first bring in all the assets that you actually watched in the previous screen, which Dr. Smith was actually staring at. So these are all the unstructured data that you're actually seeing. And these are all the medications that you just watched in that. So as a next step, what I'm going to do is actually for brevity of this demo, I'm just going to go ahead and catalog the entire bucket. You can actually catalog individual folders. But what we're going to do is to add some business metadata to the structured assets. So this is the screen where you can actually add a whole lot of business metadata. To begin with, what I'm going to do is to start adding context in terms of the README file. And this is what Navneet talked about, the context that is needed for the generative AI purposes, right? So I've added what exactly are these documents. I've provided detailed descriptions, the type of diagnosis, the medications that's there. I'm also associating glossary terms. So in the catalog, you have the ability to create a glossary in a hierarchical way and then associate terms to these. This allows you to search, and it also provides meaningful associations when your other customers who are actually working on SageMaker to understand and discover these assets pretty easily. So I'm going to go through a variety of terms and then select them and associate them for these assets. So now that we are happy with adding all those assets, let's go ahead and click yes. And you also have the ability to extend this metadata with additional concepts called metadata forms. I'm not going to do that to keep this demo short. And let's go ahead and publish this asset. So when you publish this asset, so long you've been actually just kind of working in your own local copy, so to speak. When you publish this now is discoverable by anybody and everybody. Not necessarily the data, but they can actually view the metadata. So now I just want to go to the catalog, make sure that I've actually published this right. And you can actually browse through the assets, and you can see the type of assets, the glossary terms that I associated. Very easy for me now to basically say, give me the patient data, give me the cancer diagnosis data. I can go through and look at different asset types. You might have seen like the different types of assets that we support there. We also provide a couple of other capabilities and extensions for this. It looks really great from my perspective of how I've published metadata. I also have lineage, but this is basic data lineage at this point in time because we just have started to work. And as lineage builds up, it's going to be built up pretty well in this. So what I've done so far is taken that assets that was just in S3, that was not discoverable by anybody, and I've made them discoverable at this point in time for people to come in and start working. So next, we're going to have a generative AI developer come in and do some work with this data. But before that, let's just look at a few more concepts. SageMaker Unified Studio is one of the services that brings all the structured and unstructured data together and allows you to build knowledge bases with ease. So we provide the ability in one single place for you to come in and source structured and unstructured data and then easily build knowledge bases for your GenAI applications. How many of you have built a knowledge base in Bedrock? Cool. So one of the things, and I think like all of us know, Navneet talked adequately about RAGs and what's the usefulness of RAGs. These are the concepts, or these are the objects that make your foundational model more intelligent and your organization aware, right? So by using a knowledge base, what you can do is to enhance your existing large language models to provide more context of your organizational data. And what we from a SageMaker Unified Studio and SageMaker as a whole do is to allow for you to create these knowledge bases with ease without having to navigate through multiple APIs with just simply with a few click of buttons. And I'm going to show you how you can actually do that. Now, it's one thing to have a knowledge base, but the most important aspect is even governing to make sure these models are grounded, to make sure that it's not hallucinating, to make sure that it is not being hateful, to make sure that it is actually providing the context or the right data by looking at the data that you have provided. So for this, Bedrock offers guardrails. With guardrails, what you can do is it comes out of the box with a bunch of filters that you can apply to make sure that your models are grounded, but in addition, you can also extend them with ease, with simple natural language to make sure that your prompts are the result of the large language models that you're using is appropriate. So for instance, a couple of things that you could do is, for instance, you could say, don't show PII information, or don't show I don't want you to basically be always grounded with facts. And you can do a lot with guardrails. And what is unique about SageMaker's integration with guardrails is the fact that it allows you to basically take your data from your catalog, build that knowledge base, build that guardrails, all in one single unified console, and then be able to deploy these to your business users with ease. And that exactly is what we are going to do next. So we have a generative AI developer. Remember, we just cataloged as a data producer all these assets in our catalog. As a generative AI developer, John comes in, just searches for a term diagnosis. This is a very common term that occurs for many people. They just come and search, and immediately they're able to discover that asset. When they discover, they're able to see the metadata. They're able to see the glossary terms that they've associated. And with a lot of confidence and discussions with their colleagues, this is the right data set that we have to build our knowledge base. So one thing that John does here is he's going to ask for access to that data, and this is the unstructured data access that he's requesting for. So he has requested for that access, and he can actually view that, that he's actually requested for access. Now the data producer gets this as a notification that, oh, a generative AI developer actually has asked me access. Now this is at this point in time, he can click, talk to the legal teams, make sure that they understand what the use case is for this particular asset, and then approve or reject this particular access. So in this case, after discussions with legal and other compliance organizations, they are approving to make sure that they can actually go ahead and build a chat application or to feed this into a knowledge base. So now we've gotten John access to that data. This is great. So John goes into his project, goes to the data tab, and now confirms that he now has access to that S3 buckets, which is great. He now has access. So the next natural step is to go ahead and start building the chat application. And I remember I talked about two concepts, the knowledge base and guardrails. And that's exactly what we're going to build. Look at how easy it is to build that. With Unified Studio, you just go in there and create a knowledge base. It provide the name of the knowledge base, And what differentiates things here is the fact that you can now use the data sources that you have gotten access directly from here. So I just got access to my S3 locations. I just provide that. I'm selecting the embeddings I need. SageMaker Unified Studio takes care of all the other required components, like making sure that it creates a vector database in Amazon OpenSearch, which is a serverless offering here, and make sure that it indexes all the data and creates that knowledge base for you without you having to do that heavy lifting. It's just a few simple clicks. So once the knowledge base is created, the next step for us is actually to go ahead and create the guardrails, because this is the governance application that we need to make sure that we are applying the right governance controls. And as you can see, out of the box, there is a whole bunch of filters that allow you to control the responses of the knowledge base. But you can also add your custom messages or custom prompts to make sure that you're applying your own governance controls. In this case, I don't want anyone here to prompt for address information, the demographics. So I'm going to go ahead and create a deny address, and I'm going to create a definition for it. So I'm just basically saying, like, don't respond if there's patient address information. You can provide some sample phrases that's optional for you. And we're just going to go ahead and create this guardrail. So once the guardrail is created, once the knowledge base is created, it's now time for us to create the chat app. And again, it's not too difficult. You simply go to the My Apps, create a chat app. And here we provide a name for the chat app. In this case, we'll just say it's patient 360. And we select a foundational model. We now provide the knowledge base that we want to augment this foundation model, which is pretty straightforward. Because we created the knowledge base of the previous step, we basically select that. We can apply multiple guardrails. So we'll just go ahead and apply that specific guardrail here. And what we're going to do is to save this chat app. And so we'll just go ahead and save. And next step is that now that I've been working on my local copy in my project, the most important step is to actually go ahead and deploy it so that it's basically visible to others, and I'm in a position where I can actually start sharing this with others. So we'll just go ahead and provide a name for it, or the alias name that represents that certain version, or any changes to that version. Because it's the first time I'm just deploying it, I'm just going to provide the right description for this app. And we just simply deployed that app. It's pretty straightforward, as you can see. In few steps, we basically took the data, got access, and basically built a knowledge base. And next step, we can actually start sharing this. We're going to share this with Dr. Smith. However, you can also share it with a group of individuals. Pretty straightforward in terms of how you can share this. And then we just went ahead and published this app. So in this demo, what we have done is we've shown you like how easy it is for a Gen AI developer to take assets in a very secure, compliant manner, in an auditable way, and take that and create a knowledge base out of it, apply the right governance and guardrails, and then deploy it using SageMaker Unified Studio. So now is the time when Dr. Smith comes in after his rounds. He got an email saying, look, the app is ready to share. You can start asking the questions. So he doesn't click on the link. Instead, he goes and discovers that app, and the app is there. The first thing that always prompts us is like to test the app, right? Like, oh, are you compliant? So let's go ahead and say like, hey, give me the address of a patient whom I know, Owen Anderson. Can I get the address? The guardrails kicks in. It says, sorry, I can't give you that information, enforcing that governance controls. The next thing is I'm happy as Dr. Smith to see that it's actually a chat application that's compliant, but I know of a patient. Let me make sure that I can see if that patient actually has that information that I can validate, right? Like, is the data right? So he basically asks like, okay, tell me something about Owen Anderson. The chat app is able to use the knowledge base we created and rightly summarize that information in a very clean way. The next thing, getting more confident, he asks another question. How many patients are there with brain cancer? He uses just a very simple term, not even like anything like oligodendroglioma, none of that, just a simple brain cancer. The chat app, with the help of large language model, is intelligent enough to understand the context with all the metadata that we have provided and provide like really solid responses interacting with a physician, a neuro-oncologist, which is, I think, pretty cool. And now he basically says like, look, I have a meeting tomorrow with a 24-year-old patient. She's a female. Find me patients like her. And tell me the number of comparable patients, what is the histology of those patients, tell me like what kind of treatments they've gone through, and just be grounded with facts. Don't hallucinate, right? Like he's kind of prompting the system, and the model really behaves well. It basically gets that data, provides the necessary information. It says like, look, I found a patient similar to her, she's on this protocol, and all kinds of information. Again, all of this is synthetic data that we manufactured. I can only imagine, if you start using it on your real data, I'm sure you'll get pretty good results of this. But at this point, Dr. Smith is able to get the required responses that he wanted, and he's ready to prepare for his meeting, and he's ready to go for tomorrow. So I know we took a healthcare example. You may all be from different industries, but in every part of your journey, there is SageMaker there to help accelerate through that journey. And I'm hoping that after this talk, you will go and you will try out SageMaker Unified Studio, our catalog, and we just can't wait to hear what you do with that. With that, I wanted to invite our customer speaker, Avinash from Bayer, to tell you how they're actually doing these things in real world at Bayer. And thank you very much.
Good afternoon, everyone. Can you guys hear me okay? Wonderful. I'm Avinash Shiripaka. I'm a principal engineering lead at Bayer Pharmaceutical. So Bayer is a 150-year-old life sciences organization that is driven by the mission of health for all, hunger for none. We operate across different life science verticals, combining crop science, consumer health, and pharmaceutical. So today I'm here to talk about one of the biggest challenge that we have in modern day drug discovery, that is data fragmentation and contextualization. For decades, search for new therapies has been a race against time, with massive investments pouring into R&D. But one of the biggest non-scientific challenge that we have is not the complexity of biology, but our ability to leverage existing data and accelerating AI. Data that's trapped in silos slows down our scientists and brought down critical decision making. Our mission, our team's mission is very straightforward. We are here to break down the silos, unlock speed, trust, and scale. When the data is locked in silos, we lose speed. When compliance, lineage, and consent are not clear, we lose trust. And without platform-level patterns, we cannot scale. So the vision that we have for our Bayer data science ecosystem is a platform built on the principles of distributed data mesh, along with analytical and AI workbenches, plus a central governance spine and a central catalog. We operate across vital data domains like omics, clinical, chemistry, and we operate in a distributed data mesh architecture. Think of DSC as a supply chain fabric that connects data and AI across R&D. In a data mesh architecture, the ownership of these data domains is federated to the data owners. For example, the biomarker team owns the biomarker data, the omics team owns the sequencing data, so on and so forth, while the central platform manages the interoperability and scalability of the platform. Our team solves this cross-cutting concerns by providing turnkey solutions around data ops, AI ML ops, cost hygiene, observability, monitoring, and also validated reusable templates by removing all the infrastructural concerns that bog down our scientists, where our practitioners like machine learning researchers, bioinformaticians, biostatisticians can focus 100% of their time on science and not service. And the glue that brings all of this together is SageMaker Unified Studio. SageMaker Unified Studio acts as a central governance control plane, a front door where it enables all of the capabilities and enables these data domain owners to engineer and publish these assets into the catalog. These assets are unstructured S3 tables, structured S3 assets, analytical assets like machine learning features, machine learning models, inference endpoints, agents, so on and so forth. So the seamless integration where these distributed data domains kind of merge into a unified catalog is what enables the holy grail of R&D, which is multimodal analytics. So just to quick raise of hands, how many of you are dealing with multimodal data at your organizations? Great. So search for new therapies is fundamentally a multimodal challenge. In order for us to understand a disease, a drug mechanism of action, and how a patient is responding, we cannot look at this data in isolation. So if you look at a critical domain like oncology, approximately 80% of the data across key therapeutic areas is multimodal in nature. None of this would be possible if we have our data is in silos, okay? Our internal biomarker archive, a terabyte scale of valuable study-specific data, is a clear example. It was trapped in silos, hard to access, barely findable, and generally slowing down the boat. So the challenge we had at hand was to handle this scale by still maintaining the regulatory compliance and dealing with this multimodal capabilities that we are planning to deliver. So the solution is a three-step process. The first step is where we start by ingesting our on-prem biomarker data into S3 study-specific buckets. Then we enable the trust layer because this data is GXP in nature. We enable automated Alcoa plus data controls, making this data attributable, legible, contemporaneous, original, and accurate. And we achieve this entirely by AWS native controls. Trust, by using S3 object locking mechanism in compliance mode, we ensure immutability of this data, critical for regulatory compliance. Security, with S3 server-side encryption, with KMS, we ensure our data is at rest. By leveraging S3 access grants, we make sure that there is a tight boundary of authentication and authorization controls that are in place. Auditability, by leveraging versioning and CloudTrail, we make sure the technical lineage of data, how the data is accessed, is captured, which is critical for GXP data. The second step is where our automation engine picks up. So our automation engine gets into action by provisioning all the infrastructure peripherals and the components like SageMaker Unified Studio and its underlying components for the study projects. And then it starts off by creating an authentication and authorization boundary by leveraging the S3 access grants and directly mapping them to these projects. Third step is where we register this study-specific unstructured S3 locations as assets into the catalog, immediately making it findable and self-describing. Through this process, we also capture multifaceted metadata, administrative metadata in terms of data ownership, data access, licensing needs of the data, and also domain and asset-specific metadata with rich business contextual metadata tags, creating a control layer, making this data ready for AI. We also, then the third phase is where the closed loop execution comes into the picture. Now, users start acting on this secured, governed data. The AI consumers now consume this data from the central catalog in a secured, governed manner, and they will start engineering additional assets by leveraging this data. These assets can be cross-study fact tables by exploring dimensional data, which is critical for future consent management. AI consumers can also produce additional analytical assets like machine learning models, machine learning features, agents, etc. And in turn, all of these assets are published back into the catalog. So this powerful phenomena of closed loop execution, where you consume and produce back into the same catalog, really creates a lineage-driven closed loop execution, which helps us answer question, not only who has access to this data, but what is part of this data packet. It helps us to track the journey of the data from a raw file, from a raw unstructured file, to a model, really solving the provenance concerns of a model. None of this would be possible, if we were operating in a siloed environment. This truly unleashes the capability of AI and agentic AI in the space of R&D. To demonstrate this, I want to showcase a real-time, a high-value agentic AI use case that we are pursuing in the space of biomarker data engineering. So, one of the challenge in early clinical trials is time to harmonize data. The ability for us to get data from our laboratory information management systems, from our clinical systems, running it through data engineering pipelines, QCing data is a week-long effort, manual effort, critically impacting our go, no-go decisions. So we deployed an agentic AI solution that's deployed on Bedrock, which automates this biomarker data ETL process. So first, the agent starts off by gathering information from our laboratory information management system, LIMS, our clinical systems, and our study-specific data. Then, next, it starts to parse this information. The agent leverages LLM that is fine-tuned on vector indexed on internal protocols and SOPs, and it starts to parse this data and identify the patterns. Third, the agent not only acts, but it orchestrates the whole flow where it picks the right data engineering pipeline, biomarker data engineering pipeline, and engineers the product and QCs the metrics. The final step is a result of a strategic asset where we have a multi-dimensional biomarker data cube that is further published into the catalog, which is very valuable for further analysis. So as an outcome, here we are able to remove a week's long worth of manual effort. We are able to really accelerate the time to harmonize data for pharmacokinetic and pharmacodynamic analysis, in turn accelerating our proof of mechanism and go, no-go decisions, which is very critical for clinical trial success. We are also leveraging patient data in real time, understanding the drug response, improving our success of clinical trials. So this closed-loop architecture really provides us the much-needed value unlocking that we do in terms of trust, speed, and scale. Beyond the quantitative benefits, this architectural shift also delivers quantifiable business value in terms of capturing multifaceted metadata. Technical metadata guaranteed by S3 versioning and CloudTrail logs and closed-loop execution. We are exactly able to track the journey of the data and exactly answer who has access to this data. With rich business metadata tags and contextual information that we are capturing, plus the cross-study fact tables, we are able to answer which data is actually used for this analysis. Let's say in case of a consent-based study, a patient pulls consent, the system is able to determine exactly which part of the analysis is impacted, which is critical for consent-based reusability. Our roadmap is very clear. We intend to expand our ecosystem by onboarding more data domains, industrialize our AI use cases, and truly explore the potential of multimodal analytics by impacting our pipeline, optimizing the cost and time that it takes for bringing critical life-saving therapies to our patients. In closing, our journey of migrating a 300 terabyte unstructured data, which is stuck in an on-prem environment, and turning into an AI-ready strategic asset is not just a technology story. It is a story about empowering science. We have turned an asset that was barely accessible, barely findable, and accessible only through friction, and turned it into a strategic AI asset which could streamline our pipeline activities. It could improve efficiency of our R&D decision making, and overall laying a solid foundation for our future precision medicine activities. So with this, I thank you all for tuning in. So feel free to let us know your feedback so we can improve and deliver more talks of this sort. Thank you very much.